Welcome to our second Mini Science 2018 lecture in our series entitled Women in Science at McGill. As you all know, this series is made possible through the generous support of Dr. Lauren Trottier. Before we start, we acknowledge where our series is situated geographically and historically. McGill University is on the traditional territory of the Kanien'kehá:ka, a place which has long served as a site of meeting and exchange amongst nations. Hi, Anita. Come on in. I just started. McGill recognizes and respects the Kanien'kehá:ka as the traditional custodians of the lands and waters on which we meet today. This series takes place every Wednesday evenings. Our registrar, Jessie, tells me there is still lots of room for participants. This room can hold up to 80 people. It's a great deal for students. $7, and you've only missed Madame Fortier's presentation last week and tonight Tracy's, but there's 5 more coming. It finishes Wednesday night, April 18th. Online registration, just Google Mini Science McGill. It'll pop right up. Okay. Even if you're not registered, you are encouraged to go online for background readings that are available as links through the Mini Science website that is maintained and edited by Victor Chisholm. He does a very good job of that. I don't print out those readings, but they are great readings that back up, accent, or give you more information from each speaker. Before or after, you're welcome to go to those anytime. Many of you have asked us about the videotaping situation, so I'd like to explain that. The team of AV technicians are hired. They're from McGill Communications. Jonathan is taping tonight. Stuart McCombie set it up. You will not be able to access these webcasts until after the entire series is finished. Then they mount them on their platform, so you will be able to watch each speaker and thumbnail images of their slides. Those will be preserved, archived forever, but only after the entire series is finished. This mic picks up me, it picks up the moderator, and this is what we will use at the end for the question period. We used to write down our questions. I still brought the question cards just in case you want to formulate a question in writing while the speaker is on. But then let's use this mic. Our volunteers will be passing this mic around for the question period after Tracy finishes her presentation. Special thanks tonight to all our volunteers. And the one person I didn't mention, Faggy Covens, she orders our snacks. Please let her know, let us know on your evaluation form if there's anything special you would like catered, beyond, within reason. Because people need a snack at this time of the day, and the chef, those cookies he told me were specially prepared for tonight, low sugar, high fiber, and the apples, once they sent them all wrapped up in plastic, and that was really not a good thing. So they needed to know that. That was very wasteful. So things like that, please don't hesitate. You have those evaluation forms. We look at them. We look at your comments. They help us to improve this series. If you've not already done so, please turn off your cell phones, Blackberries, or other devices that may disturb the audience. Our moderator for tonight is Professor Anila Ajgar, the Associate Dean of Education at McGill. She will now introduce our speaker.
Thank you, Ingrid. Good evening. It's really an honor to be in the company of an academic star tonight and all of you, and a pleasure to learn about her wonderful work. And I also have the honor to introduce our wonderful speaker. Professor Webb is an associate professor within the physics department of McGill University and a member of the recently created McGill Space Institute. She is an observational astronomer who uses light at many wavelengths to study the formation and evolution of galaxies. In particular, she is interested in exploring the physical processes which took the small fluctuations in the early universe and turned them into complex structures. With her research group, she has been using the world's largest telescopes to observe galaxies as they existed when the universe was much younger. She is interested in understanding when galaxies form the bulk of their stellar mass and what drives and later shuts down this process. How does the local environment of galaxies affect their evolution and growth? And what role do growing supermassive black holes play in galaxy assembly? Isn't that wonderful work? I want to learn more. Although she gathers data at many wavelengths, she focuses primarily on what we can learn from infrared observations. She first studied for her undergraduate degree at the University of Toronto and finished her PhD in astronomy and astrophysics in 2002. In between, she went to McMaster University in Hamilton for her Master of Science. Before starting to work as a professor at McGill University, she worked as a Vennie Fellow Leiden in the Netherlands Leiden Observatory, University of Leiden. She has won many awards and scholarships from McGill University, from the Natural Sciences and Engineering Council of Canada, from the Canadian Astronomical Society and the Royal Astronomical Society of Canada for the most outstanding doctoral thesis in astronomy or astrophysics in the preceding 2 calendar years. So please join me in welcoming our wonderful speaker tonight. Looking forward to your talk.
Thank you very much. I just realized I haven't turned off my own cell phone, so I should do that. There we go. So it's really great, a great honor to be here and lots of fun to be able to come and talk to everyone here tonight about women in physics. I missed the first lecture with President Fortier, so I'm flying a little blind, and I hope that I've put together an interesting, eclectic mix of anecdotes and factoids about women in physics, particularly at McGill. But I would like to just emphasize at the very beginning that I would very much like to keep this as informal as possible. This is a great room for it, and if you have any questions, please don't hesitate to interrupt me at any time. And I'm happy to keep the talk formal and more like a conversation. Right, so before I get started, I wanted to just give you a little bit, I hope everyone can see this, give you a little bit of an overview about what I'm going to be talking about. As I said, it's a bit of an eclectic mix of factoids about women in physics as well as some science. So I would really like to talk to you about some science as well this evening, so we'll do some of that as well. But I would like to talk about what it's like to be a woman in physics, in particular at McGill. Because I'm a physicist, I'm a scientist, I want to present some statistics and data so that I back up what I'm saying, because there's actually some really superb data out there now about women in physics. And in fact, I just attended a talk a week ago in our physics department, which I'll tell you a little bit more about as we go through all this information. You've heard a little bit about my own career path. I'm going to highlight that as well, just so I can use that as a means to highlight some of the places where I feel, not that I've had trouble, but things that were particular challenges to me as a woman in physics. And some of these things are unique to physics and some of them are not. Some of them are just unique to working hard in the world. And then finally, as I said, I want to talk some science. So I'm going to talk a little bit about my own science, but what I've tried to do is put together really one slide per woman at McGill, which is fantastic because there's actually a lot of women at McGill. So it turns out there's a lot of slides I have to go through. So I'm going to try and highlight some of the physics that is done by these women at McGill. In particular, I'm really hoping that I can inspire some of the younger women in the audience and show you what kinds of different physics you can do at McGill or at any other university as well. And also just to give you a feeling for the broad diversity of what we do here at McGill. The two things I just wanted to say I'm not going to talk about, but I am happy to field questions on, is really the history of women in physics at McGill, which is a talk unto itself. There have been some very notable, famous, wonderful women who have paved the way for everyone who works at McGill now and indeed in Canada and the world. And you can learn about them. You can learn about some of the women in at McGill at a wonderful exhibit that I just saw outside the door. We also have some archival and historical artifacts in the McGill department as well. We have a little museum there, and you can learn about people like Anna McPherson as an example. But I'm not going to talk about that. I'm really going to talk about the present day environment of women in physics and what's happening at McGill. I'm also not going to talk about how difficult my experience has been because I really want to keep this upbeat. And in fact, my experience as a woman in physics has been very positive. And so again, I would like to use this opportunity to encourage any of the younger women in the audience, really to tell you that physics is a great career, man or woman, and it's really worth pursuing. And there's more good news than bad news. Okay, so let's start with the faces of women in physics at McGill. So I really, like I said, wanted to start with the present day. This is what our women in physics at McGill, the women in our physics department look like here at McGill. There are 9 of us, and I'll go through them all in detail when I talk about their science, so I'm not going to tell you all of their names. I'm up in the left-hand corner there. And other than the fact that I think it's a great-looking group, I wanted to point out a couple of things that you might, of course, notice about this collection of faces. One is that there are, I'm really excited that there's 9 of us, but that really is quite a small number when you compare it to the overall number of faculty in physics, which is 45. So that's about 20% of the faculty in physics. So we are still quite a minority within the physics department, even though there's almost 10 of us now. The other thing that you might notice is that all of these faces are relatively young. So our most senior person is Vicky Caspi, who I'm sure everybody's heard of. She was hired roughly 17 years ago now. So everyone here has been hired within, say, the last 15 years, give or take a couple of years. So this is, of course, one of the things I'm going to be highlighting again and again, which is that, as you know, there haven't been historically a lot of women in physics. And it's really just today that we're starting to take off and really reach potential to start inclusion, to have a field which recognizes diversity and inclusion, and really starting to bring women and, of course, other minorities into the field as well. But again, I want to present this as a really positive thing. Everybody's smiling in these pictures. We love our job. It's really great. But this allows me to sort of segue into the data. So as I said, I wanted to touch on some of the statistics and data that have been gathered by people who study women in physics and women in other sciences to place McGill in a more global context. So it's really great that we have, 20% women in our physics department, but how does that compare with what we see, I'm not going to talk about globally, but at least within North America? And also, how have things changed over the last couple of decades? So the fact that there are fewer women, that there are a minority of women in physics, that women make up the minority of physicists, is probably not a surprise to many of you. We've all gone through school. And we know, if any of us took physics classes, you probably looked around you in your physics class in high school and noticed that there were a lot of guys in the room. So this is something that goes right to the beginning of physics education, and that's what I wanted to show from this slide. Before I talk about the data on this slide, I just wanted to highlight where it comes from, which is the American Institute of Physics, the Statistical Research Center. And this is actually very recent data. This was from March 2018, so very, very recent. And it unfortunately only goes up to 2013. This is because the IAP gathers data in chunks of, I think, 4 years or 5 years, so their data is just coming in for the next chunk. This is an association in the United States. They have this huge statistical research center, and they've been collecting data from all of the degree-granting institutes within the United States for decades. So these data go back to 1985. And so I'm going to be showing you a lot of the information that they've put together, bearing in mind that this is all for the United States. It's because they have such a huge population that these statistical studies are possible, and people are trying to carry these things out in Canada as well, but the numbers are just so much smaller that it takes a long time to really put together the trends. Okay, so what this plot is showing is actually the percentage of women, or females, women and girls, in high school physics, either as a function of all high school students or all high school physics students, and over the last several decades. And what you see, of course, is the orange line is fluctuating around 50%. Girls make up roughly 50% of the population, and so 50% of the high school students. But the number of girls in physics classes is systematically lower than the number of girls in high school. It's not down at 20%. It's still up around 40, 45%. But it is lower. And I really just wanted to take this to show you that this problem of low numbers of women in physics goes back to the very beginning of physics education. And in particular, what the data are consistently showing again and again and again is that we lose girls in physics in particular as soon as they have the option to opt out. So this is kind of a confusing plot because it doesn't really take into account, it doesn't show you how many of these courses are mandatory, how many of them are optional. This really varies from high school to high school. I know in my own training, my own education, physics was an option. And so, again, in my own physics class, there were very few of us girls. But probably why this is so high is that in many of these high schools, physics is still mandatory. So it's hard to fully interpret, but the numbers come down because women can drop out, girls can drop out. And of course the question is why, and that's not something I have an answer to, and I think no one has an answer to that. There's lots of different theories, of course, and we can talk more about that during the question period. This is a plot showing the percent of physics bachelors and PhDs earned by women in the United States, again going back to 1976 and up to 2016. The really great news that you see here, these are PhDs in red and bachelors of science in physics in green, is that it's really been increasing with time. So way back in 1976, we were down less than 10%. And now, both in PhDs and bachelors, we're hovering around 20%. And so there's been a really marked increase in the number of women earning graduate degrees in physics over the last several decades. The bad news, of course, is that there's very little data here, but it seems to be plateauing at 20%. Especially the bachelors have not continued to rise. And I'll show you some other data where these numbers have risen, of course, in other areas of science. And so there's something happening in physics where it seems to be plateauing around 20%, which is this magic number where we are in McGill right now in terms of faculty. This is a plot that shows you the percent of bachelor's degrees earned by women in different areas of science. And the thing that I want you to take away from this particular plot is that there's nothing special. It's not that women are bad at math and science. And I'm sure no one in this room thinks that they are. But what you see here is a very busy plot that shows you the percentage of women earning bachelor's degrees in various different fields of science. We have biology in orange. All fields is blue. Biology is in orange. Mathematics is this line right here. Chemistry is this line. And then there's this huge gap before we have engineering and physics. and computer science, actually, as well. And so there's something in particular, there's something different about the very hard, I don't mean hard as in difficult, but what we tend to refer to as the hard mathematical sciences, computers, engineering, physics, except for math, which is very, very interesting, that women sort of steer away from. Again, they drop these courses very early on in their education. But women are great at science and great at math. And in the other fields, they dominate even. So in biology, it's more than 50% women now in the biological sciences, something you probably know. So there's something really, really strange about these particular divisions in science. And I'm not going to pretend to have the answer. There are lots of different ideas floating around, but I think that nobody really knows. The best people to ask are going to be young girls, I think. Okay, so let's put McGill into context then, as I said I wanted to do. This is a histogram that is showing the number of PhD granting physics departments divided up according to the number of women, not the percentage, but the actual number of women that they have in their department. And we have 3 sets of times. 2006 is in the light gray, 2010 is in dark gray, and then 2014 is in blue. And so these are the number, for example, of PhD granting physics departments in the United States that had no women on faculty in 2006, 2010, and 2014, for example. And so here you can see an interesting trend, which is that in 2006, there was 15% of the PhD granting institutions didn't have any women. And that has been decreasing as a function of time. If we go over to where the numbers get larger, 4 or 5 more, you see the opposite trend. So at early times, 2006, there were small numbers, small percentages of these institutions that had lots of women, and the numbers have just been shooting up. And so this is really, really encouraging. And again, you can see here that this is now at something like 20%. 20% of the PhD granting institutions have at least 5 women on staff. Why is that important? I mean, I think it's fairly obvious that one of the things we want to do if we want to encourage young women to go into physics is to create role models for them. And if you have no women in a physics department, there are no role models for those young women. It's also not good to have 1 or 2 women in your physics department, not only for role models, because that's, well, there are various reasons. It's a lot of work to put on 1 role model. Also, not one size doesn't fit all. Women are different, and it's nice to have various role models, women with children, women without children, women who have come from industry, women who have taken a linear path. It's nice to have a variety of role models as well. But it's also very isolating for that poor one woman who's working in that department. So it's really great to see this trend where we're increasing the total number of women in departments. Of course, I'd like to highlight that McGill lives over here with 9, so which is really fantastic. And to segue into the next thing I want to talk about, I'll just note that this is where I did my training at an institute that had no women whatsoever. So I had no role models, no female role models. I had lots of male role models, of course. So I want to spend, so that's all the statistics. I didn't want to overwhelm you with data, but I'm now going to talk a little bit about my own career path and talk a little bit about some of the challenges that I have encountered as a woman in physics. So I put together a little spreadsheet, not spreadsheet, a flow chart to show you, there's 2 pages of this, to show you basically how I got to where I am today. And I'll start everything out by saying that I had what I've called a very linear path to academia. I did everything that if you were to write an instruction manual as to how to succeed in physics, I followed that instruction manual. I mention that only because I want to make sure to state that there are various ways of getting to where I am today, which is a professorship at a research-intensive university. I have colleagues who have come from industry, for example. I have colleagues who have done teaching first and then have returned to research. There's many different ways of getting there. But what I'm going to describe to you is a very typical path. So, is this a pointer? I'll just wave. I'm originally from Ontario, near Toronto, and because we've been talking about the low numbers of girls in physics, I wanted to state from the very beginning that I have always been interested in science, and in physics in particular. So I wasn't one of those kids that dropped out of the physics classes. I was excited to take those physics classes. I was excited by all of our science classes in school. And I mention that really because I think that okay. I'm trying to just gather my thoughts here for a second. The problem with women in physics, or studying women in physics, is that we're usually studying the women in physics. So women who have always been interested in science, who are always interested in physics, who have made it their life's ambition to be a physicist and have succeeded at their career. And we go to them and we say, why aren't there more women like you? And of course, we have absolutely no idea, right? Because we don't understand why everyone's not a physicist, because it's such a wonderful thing. And so I'm really the wrong person to ask, because I wasn't the girl who dropped out of those physics classes. And so I really just wanted to make that clear, that I think, when we're looking at women in physics and the problem of getting girls excited in physics and computer science, we need to be talking to those girls who are dropping out and asking why they're dropping out, and what we can do to keep them there. As I said, I took every science credit I could in high school. I also wanted to state that I was a very enthusiastic but not a top student. So if there's anyone in this room who thinks that they're not smart enough, and I'll come back to that as well, let me tell you, you are. Enthusiasm is 90% of the job. Yeah?
Did you come from a science family?
Did I come from a science family? No, I didn't. My dad's an accountant, and my mom is a teacher of French literature. Yeah, and they also basically just have undergraduate degrees. So I didn't come from a family that had a history of higher level education as well. So I don't know why I ended up in physics. As I say, I don't know why everyone doesn't end up in physics, though. I went directly to do a bachelor in physics and astronomy at the University of Toronto. So this was a joint degree that they still offer. You take a physics stream with a specialist in astronomy. This was 4 years. I wanted to mention here that this is actually where I met my husband, and I'll come back to why I'm telling you about meeting my husband a little bit later. But he is also a physicist, and I met him in my first year physics class. I then went to McMaster, as you've already heard, to do a MSc in physics in Hamilton, Ontario. That took 2 years. And then back to the astronomy and astrophysics department at the University of Toronto for a 4-year PhD. So it's a 10-year process to get your PhD. It's like going to medical school. Yeah?
Tracy, I just want to get some perspective on you the only female, for instance, in the BSc in physics.
No, I was not. I believe
Were they low numbers?
they were low numbers. I think there was about 4 of us.
That's still...
It was low. Again, it's difficult. It depends on how you count people. There were people in medical physics, mathematics and physics, geophysics. Those of us in the physics and astronomy program, I believe there was 4. out of 20. 20? Yeah. So it wasn't terrible, but it was it was a small group. Yeah. I have a funny story actually about when I was doing my master's at McMaster. There were quite a large number of women at the master's level when I was there, and we had to take core physics courses because it was a physics department. And so we all had to take quantum mechanics. And it just so happened that year, everyone in the quantum mechanics class was a woman. And the instructor, who was a lovely man, walked into class on the first day, looked around, and walked out again. Because he thought he was in the wrong room. And anyways, it was a very nice class in the end. But, your perceptions. So I think that this is, I'm going to say that this is part of the reason why the numbers are low. It's a long haul. But you can say the same thing about becoming a doctor, and there's lots of women doctors. So it's not just that. I then, again, as you heard, went to do a postdoctoral fellowship in the Netherlands. It's basically mandatory in my area to go outside of Canada to do what's called a postdoctoral fellowship. So this is your years of independent research that you do in between your PhD and getting a professorship. And you need to get international experience because it really is a very international field. So the reason I'm highlighting this is because by that point I had a partner, my now husband that I met in physics class, and of course I had to leave Canada. And he was still working on his PhD at the University of Toronto. And so this was my first experience with a very well-known phenomenon in physics, which is called, we call it the two-body problem. This is a play on, yes, everybody gets it, okay. So I went to the Netherlands and he stayed here, and we had a long-distance relationship for about 2 years, and then he joined me in the Netherlands. But this two-body problem was wonderfully solved in 2006 because we both got positions at McGill. And Ingrid was just actually asking me about that. We were very lucky in that there were 2 positions on offer at McGill that we each applied to independently and got. Whereas McGill, as you may or may not know, is also very proactive at hiring couples. And so they will, if they have a woman come into the physics department, and we have lots of examples of this, as I'll show you later, and she has a spouse in physics, they will do everything that they can to produce a position for that spouse as well. Or if the spouse is in biology, then there's negotiations with the biology department. This two-body problem, as I'll talk about later, is recognized as one of the main difficulties in hiring and retaining women in physics, for reasons I'll explain later. And then I had 2 kids in 2007 and 2009 after I arrived here. I was tenured in 2014, so I became an associate professor. And again, I'm mentioning this because I delayed my tenure application because of my children. And I was actually the first pre-tenure person in the physics department to take parental leave, male or female. So just to give you a feeling for the culture, that they had never experienced this before, somebody having a baby before tenure. Yeah, and in fact, they'd never really experienced it at all with a woman. So I say pre-tenure. The other woman, Vicky, basically had tenure. Well, she also didn't go on maternity leave. It's a very complicated story. So it was a new experience for the physics department, I think, just to put things in context. And I was the 3rd tenured woman actually, I think that this is wrong. I was doing some reading just before I came here, and I believe there was actually 1 associate professor before this, who was Anna McPherson. So I think this should be 4. I've taken on some administrative position now as well. I'm the graduate program director from 2017. And so the next step in my career is full professor. So that's my career in a nutshell. So let me talk about some specific personal challenges that I encountered that, as I say here, are related to, but I would like to highlight not unique to being a woman. I know many, especially the new generation of men, who suffer from some of these issues as well. And the first one I want to talk about is something known as imposter syndrome. And who's heard of imposter syndrome? Everybody. So I don't have maybe half. Okay, maybe not everybody. So I looked it up on the internet, and it officially is a concept describing individuals who are marked by an inability to internalize their accomplishments and persistent fear of being exposed as a fraud. And I suffered from imposter syndrome, and almost everyone I know has suffered from imposter syndrome. So I like to put that front and center, again, for the young women in the audience, that you are probably thinking as you sit in your physics class that you don't belong there, and everyone is thinking the same thing. And this is something that crops up in all high-performance areas, so not just physicists, although I'll show you some data associated with that in a second. But I'm sure high finance and doctors, anyone who is called upon to perform at a high level over and over and over again is always worried that someone's going to find out that they've been faking it the whole time. So I struggled with this a lot. I also struggled with the two-body problem, as I said. So this is not unique to me. 4 of the 9 women at McGill have partners who are also employed by the McGill Physics Department. So 50% of us. And most women, statistics show that most women in physics, academia, have partners in a similar field. So that is some sort of physical science. If not a physical science, then it's more likely to be a regular science, like biology, doctors. And then even if they're not with someone who is in a similar field, they're often with someone who is in another high-powered field. And why is this important? Because, of course, it makes it very difficult to find a job and also retain that job if you're both if you both have very, very strong career goals. It's hard enough if you both have strong career goals. It's even harder if you both have the same career goal, which is to be a physicist at McGill, because the turnover rate in professors is very slow. And so, as I said, we were very lucky, in my case, that there were 2 jobs available, but I'm the only person I know of who experienced that. Everyone else I know of who has managed to solve the two-body problem usually does it through negotiations with the university. Family-work balance is, of course, hard to maintain. I've got 2 kids. It's hard to be a perfect mom and a good scientist at the same time. Like I say, none of the things I've mentioned so far are unique to women, but they are more prevalent with women. I would say, obviously, that my husband had to also deal with the two-body problem. He's also had to deal with a work-life balance issue because he has a very busy wife. And then finally, something that not finally, but almost finally, something that we often don't think of in academia that complicates things is that when you're in academia, and when you're a physicist, but academia in particular, you often are forced to relocate into a new city. And this is, again, because the jobs are so precious. You take what's available. And so I'm not from Montreal, as I said. I'm from Toronto. And when we moved here, we had no family, no friends, no network. And this, of course, also makes it very difficult to succeed, given everything else as well. So I think that these are 4 things that, like I said, are not unique to women, but make it difficult to succeed within the field. And I also finally want to say that one of the main things that I've struggled with as well during my career is being taken seriously. So this is a direct quote from someone, I don't know who, but someone on my hiring committee who said that maybe they shouldn't hire me because I didn't have the gravitas to teach physics. I had to look up what gravitas meant. And it is dignity, seriousness, or solemnity of manner, used as an example, a man of gravitas. So it's something that is often associated with very powerful men. And there was a worry that I didn't have that. One of the articles in the reading associated with this lecture is this idea of not looking like a physicist. And this is something that I have struggled with even my undergraduates when I teach them, is that they expect a certain type of person to be informing them at the front of the room. And I don't meet I don't meet what they expect. And I think things are changing now, but again, if you do so this talk that I was just at last week, she did a little example where she typed in physicist into Google images, and you see the pictures that come up. And I didn't do this, but you can imagine what Einstein, Stephen Hawking, Niels Bohr, all of these very, very famous white men. And this is a real problem, I think. And something that I think the only way you can overcome is by being serious and teaching people to take you seriously. And as we have more and more role models in our physics departments, that will change. But of course, this is, again, not unique to being female. Visible minorities have the same problem as well. I'll talk a little bit about, as well, some of the general challenges as reported by professional organizations. So again, I'm going back to data. There are some really neat studies that have been done in physics. One of them, this is actually Canadian, has been done by the NSERC granting agency. And basically what NSERC has found is that women don't do as well as men when it comes to earning grants in Canada, which may surprise you. This particular plot that I've stolen from their website is showing the ranking of NSERC grants. So just to give you a little bit of background, NSERC provides in physics, our main operating grant. So it gives us all the money that we need in order to carry out our research. We ask for a certain amount of money, they always give you less than you ask for. And the way you get allocated your money is basically by being ranked as exceptional, very strong, strong, and then of course there's all sorts of horrible rankings below strong, like average and whatnot. And this is showing you women in pink and men in blue as a percentage of the rankings. And what I hope that you can see is that the exceptional candidates are always men, very strong, and then the strong ones are always women. And this is why, one of the reasons why women seem to do poorly on their research grants. They get given less money, so they have less resources to carry out their research because they seem to be consistently ranked lower than men. Now, of course, one solution to this is that women just are not as exceptional as men, but that's not something that I would want to start with. My guess is that there's some bias going on in here as well, and there's lots of studies to back that up, that we don't have a blind system. You know who you're reviewing, you know their age, you know their gender, you know a lot of different things about them, and this all goes into this bias effect. I wanted to highlight again the imposter syndrome because I think that is a really, really big problem in our field. This is again from the American Institute of Physics, where they did a survey on imposter syndrome, and they basically asked this question to astronomy graduate students, so this isn't all physics. Sometimes I am afraid others will discover how much knowledge or ability I lack. And the students were asked to agree or disagree with that statement. Basically half, male and female, agreed or strongly agreed with that statement. So it's everywhere. But systematically, women show or exhibit imposter syndrome more than men do. And I think part of this is because they look around the room and they don't see themselves in that room. And so it's easy to feel that you don't belong if you don't see yourself reflected in your peers. And then finally, something directly from my own field of research, which is astrophysics. And I'm just trying to keep an eye on time here because I want to maintain time for science and questions. This is, again, resources. So in my field, one of the things we compete for in addition to money is telescope time. And so I apply to telescopes in order to win time on these telescopes, like the Hubble Space Telescope, for example. And this is data from the Hubble Space Telescope. They've been monitoring their proposal success rates for many, many years now. Cycle is basically a year. And what they have found is that women are systematically less successful than men. And that's what you can see here. These green histograms are always less than the red histograms. So green is women, red is men. And in every single cycle, women are systematically below men. Not by a huge amount. It's not something you would necessarily notice unless you've carried out the statistical study. And so, similar to orchestras, what the telescope has now done is they've moved to blind review systems. So you no longer know who is the principal investigator on the proposal that you're reviewing as a committee, because committees of peers are the ones who are evaluating these proposals. So you no longer know if the proposal that you have is being led by a man or a woman. And my understanding, it's not shown on this particular plot, but my understanding is that has made this bias go completely away, which is fantastic. Okay, I'm going to skip over that last slide because it's sort of superfluous, and I want to spend just the last few minutes talking about some science and giving you an overview of the kinds of science that women do here at McGill in the physics department. And I'm going to start with my own. As I said, I'm going to try and do this really quickly, basically one slide per person. And I can answer questions as best I can. I can answer lots of questions on my own research, but I am less able to answer questions on, for example, Sarah Harrison's work on string theory. So what I do, as you heard, I'm an astrophysicist, and I'm an observational astrophysicist. I gather data, and I essentially like to describe what I do as using telescopes as time machines. I use the fact that light takes a finite amount of time to travel from one galaxy to our galaxy. I use that fact to allow me to look back in time and see galaxies as they existed billions and billions of years ago. So I use telescopes like the Hubble Space Telescope to do this. And I take images like this one, and my fundamental questions are, why does the universe look the way it does? Is there one galaxy here that's a big red ball versus another galaxy here that's a beautiful blue spiral galaxy? Why are they all full of stars? Why are they full of dark matter? Why do they all have supermassive black holes at their centers? I want to understand how all of this got to be. So another one of my colleagues is Professor Brigitte Vachon. She is an experimental particle physicist, and I I'm going to see if you guys notice a couple of things as I go through this, and I'll tell you at the end. So she's an experimental particle physicist. She wants to study what the world is made out of. So she studies the fundamental particles like quarks and protons and electrons, and tries to understand what is called the standard theory of matter. She builds instruments. So one of the instruments that she is famous for participating in is the Atlas detector, and this is her pointing at it here. And this is just a picture of the kind of data that she collects. So this is an image, a computer-generated image of a real proton-proton collision at the Large Hadron Collider in Switzerland. A new hire, someone who's actually just coming in September, is Cynthia Chang. She is also an experimentalist, and she builds telescopes. And she builds, I think this is really cool, and I don't mean this in a bad way, but she builds telescopes, I think, that are held together by duct tape. Like, it's just fantastic what she's able to do. And so she builds these telescopes on very, very remote locations on Earth where the sky is very quiet. And she's interested in understanding what the universe is made of, how it's evolving, what happened really in the first few minutes after the Big Bang. Whoops. Then there's Lily, Professor Childress. She studies quantum mechanics. So I just took this from her website. She uses coherent, controllable quantum systems. And she works in quantum optics and quantum physics, really to get at quantum information science. And so what is she doing? She's studying these materials that have these very small defects in them that behave very strangely quantum mechanically, and you can use them to store information and do other really neat things. There's Tammy Pereng-Bernuya. She's condensed matter theory. So again, she's also doing a lot of quantum mechanics, and she studies things like superconductivity or topological properties of materials. So there's this nice picture of a piece of material here floating above a superconductor. So, but she's a theorist, so she doesn't have a lab. She actually thinks and works these things out on paper. Not that experimentalists don't think, but of course, we have our famous Vicky Caspi. So for Vicky, I just said Vicky Caspi, pulsar hunter. Vicky leads many of the world's top searches for pulsars, which are dead stars, which basically emit light very similar to a lighthouse. So it has a beam of radiation that sweeps through space that we can detect. And this is just an artist's representation of what a double pulsar system might look like. So she finds these things, and then, of course, she studies them as well. And she's now involved in a really big project called CHIME, which is to find thousands and thousands of pulsars. Well, what we think are pulsars. These very mysterious things known as fast radio bursts. Another new hire is Daryl Haggard. She's also an astronomer. She studies the centers of galaxies, and one galaxy in particular, which is our own Milky Way galaxy. And this is a movie of the variability in X-ray light coming from the center of our own galaxy, the Milky Way, which is actually a very, very busy and crowded place to study. She's also become quite famous lately because she has been involved with X-ray follow-up, X-ray imaging of this neutron-neutron star merger that you may have heard of, which created gravitational waves that we've detected with the LIGO detector. So gravitational waves were detected, and she was one of the astronomers that then slewed an X-ray telescope to the location and was able to detect the galaxy that in which the neutron stars were colliding. We have Sabrina Leslie, who images biomaterials. So she's a biophysicist, and she works with very novel techniques to do things like study DNA molecules. And so these are just some pictures of some of the people in her lab. She's an experimentalist with a laboratory studying all of these different interesting biomaterials. And then finally, we have Sarah Harrison, also a recent hire. We're all recent hires. And she is a string theorist. She's cross-appointed between math and physics. And she's interested in understanding really the fundamental theory of the world in a mathematical sense. So before I finish up, I thought I'd just quickly ask if anyone noticed some similarities in that group of women.
A lot of them have curly hair.
That's true. A lot of them have curly hair. Which is, yes, that's the Einstein effect. I was thinking that experimentalists, there's a lot of experimentalists. So again, for reasons that we don't fully understand, if you even divide up different areas of physics into, for example, theory and experiment, women tend to flock towards experiment versus theory, for reasons, again, that we don't really know. There's also a lot of astronomers in that group. Astronomy, for, I think, historical reasons, has a very high percentage of women compared to the other physics. So I'll just finish by saying that together we've formed what we call the Women in Physics, or WIP. We have a website. We are an organization with the mandate of fostering an inclusive environment in the physics department, supporting the women in our department, and spreading the message about the importance of diversity in the field. This is possible because there are so many of us. It would not be possible to have a Women in Physics committee if there was only one woman in the department. Well, unless it was all men, of course. So we're really lucky in that we even can swap in and off of this committee. We don't have to do it all the time because there's 9 of us. It's really fantastic. And we try and create role models for the students. We have a lot of different initiatives. We have breakfast with the speaker. For example, when the speaker is a woman, we have a special event where other young women in the department can come meet the speaker. The kids do a pub crawl. We do mentoring. We have this special colloquium. We've just developed a new parental leave policy for our graduate students and other special events. So there's really something about having a critical mass of a large number of us that is really starting to allow us to get some real stuff done within the physics department.
When was that formed?
5 years ago, maybe? Yeah, I'd have to look that up. So it's not been around for a long time. So I'll just finish, again, for the young women in the audience. This is just a shot of the Canadian Conference for Undergraduate Women in Physics in 2018. I chose this because it was the best picture I knew of lots of women in physics. This was at Queen's in 2018. I hope that I have, in this talk, shown that physics is a really exciting place to be. It's not without its problems, but really the problems are one of getting women into physics. There's not a lot of problems once you arrive. And so that's really where we need to concentrate our efforts, is getting young girls interested in the physical sciences. And I'll stop there and take questions.
Thank you very, very much for
Thank
a
you.
very, very thought-provoking and enlightening and interesting and wonderful talk. And on behalf
thank you.
of the organizing team, I would like to present.
Thank you very much.
We have to use the mic, so Heather.
Thank you. Is this on? Pardon? You can hear, okay. Thank you, that was a really interesting talk. I'm curious about, well, I have two things, but I'll ask just one. The way that people have to dress to get gravitas, and it's something I think that many women struggle with. Do you feel that a lot of young women are put off because they have to make a choice between expressing femininity and working in something like physics? And if so, what would you recommend?
So I think that this is a real problem, and I can point to several incidents where this topic has sort of reared its head. Again, just a personal anecdote. I was told by a senior male colleague when I got as a postdoc, when I got my professor position, that I would have to reconsider my wardrobe. Yeah, I thought I was dressed fine, but he felt that I needed to, I think it was this gravitas thing. There's also, does anyone remember a few years ago there was this really big incident where there was a video made of girls in a lab, and they were looking very feminine. They had their nails done, and the whole point of it was to try and appeal to young girls who like that kind of thing and show them that it's okay to be feminine and also be a physicist or a laboratory scientist. And that created a huge ruckus. It's something that I would say in my conversations with other young women as I moved through my career was something that was we were all very acutely aware of. And I think that I mean, every field has a uniform. And if you want to be part of that field, you adopt that uniform. But I think I can remember having a conversation with another female physicist who said flat out, I'm going to dress like a woman and I don't care. And everyone kind of said, oh, I was like, what does that mean? Are you sure you want to do that? But now, you know, I think that as, again, more women enter the field, that uniform is changing. And it really is just a matter of getting the numbers, changing what we think of when we think of a physicist. And if we think of women, then we'll think of women dressing as women, and not just dressing as men. Yeah, so I'm not sure if that fully answered your question. Yeah, okay.
I also enjoyed your talk very much. One of the things I noticed when I was visiting the physics department, once they had these, I guess, monthly talks
the talks,
or something.
yeah.
And I noticed that a lot of what they do is build machines.
Yes.
And I thought in terms of recruitment that not so many girls get experience doing mechanical things, working with them, and that they may feel that this is going to put them at a disadvantage when they go into physics if they haven't done any of that in high school, that somehow they won't really understand how the gears work or how something or
Yeah.
other, you know, and that could be a deterrent.
Yes.
So that was one thing I wanted you to comment on. And the other was in terms of the maybe slight preponderance toward experimentalists. You know, sometimes there seems to be a hierarchy of intellectual subjects, and experimentalists probably have a greater opportunity to use data to prove their worth because they're gathering material and you
Yes.
can't argue with it.
Yes. Yes.
Whereas in theory, you can kind of push it away until something dramatic happens. But
Yes.
So that was
Yeah.
another thing that I was wondering about. And I guess if I would be so privileged to add one other question that was lurking behind some of this, is that it seems in many fields where men seem to gatekeep women out of the field for a long time, the women who make it in often do so with a male partner, and it's easier to break in if you've got a partner in the same field, because the other men aren't going to hit on you and put you in the position of being a female sex object. And so that might be something that's changing. I don't know. So I'd like you to maybe comment on.
Okay, so you
those.
might have to remind me because there's three things.
The first
and I
one
might-
is a mechanical
yeah,
experience.
mechanical
The second
experience.
was experimentalists. The third was
Right.
husbands.
Right. So I would say I think I think this is a huge issue. I have no data myself that I can point to back this up, but I think that physics is a very hands-on, very buildy profession. People are building their experiments, they're playing with circuits, and I think we probably all can agree that that is something that we very much encourage in young boys, and less so with girls. And I don't think that's a controversial statement to say that. I find myself doing it. I have 2 young nephews and 2 young daughters, and I very naturally gravitate to different toys for each of them, and I have to catch myself. And so I think that that is something that we need to work on as a society, really encouraging women to tinker, to learn how things work, to do the kinds of things that we've been encouraging boys to do for, centuries, really. And I think that that would go a long way, and showing them that it's okay to be a girl and to build a police station with Lego. You can be both. I remember when my young daughter wanted a train set, and it had to be pink. And we searched everywhere for a pink train set. And, she wanted to play with trains, but they had to be pink. And it was impossible. We eventually found something. But I think that genderization of our kids happens very, very early. And it's one of the reasons why it doesn't, I think that girls just don't feel like it's a girly thing to go into physics and to do things like build radios or telescopes with duct tape. And so it's something that we need to change. Experimentalists, definitely there's a hierarchy within physics. The theorists, and again, I don't think this is a controversial statement to say that the theorists live at the top of the hierarchy in terms of intellectual ability, and the experimentalists live down here. And that may, again, be why it's easier for women to enter into the sort of lower rungs of the physics ladder. You see, one thing I didn't really talk about, but you see the division between men and women very starkly as well in levels of administrative positions. So positions that have power, running telescopes, running all go. The number of women who take on those positions is very low. And so again, we see women at the bottom ranks doing the work, but we don't see them up high yet. And I think a lot of that is, as you say, a hierarchy that some of it is the fact that women are just in physics still tend to be very junior because they haven't been in physics for a long time. But a lot of it is a hierarchy thing. Yeah, and I definitely take your point that you can't argue with an experiment. You build your experiment, you get your data, but theorists, there's a lot more posturing and convincing, and you have to be loud and argumentative, a lot of these things that we don't naturally associate with femininity. And then as for your last point about husbands, it's not something I thought of before. It is, as I said, true that most women in physics have a partner in the physical sciences, not everyone, but a lot of them. I've always sort of thought of that as you often end up with people who can understand you, and physics is a very demanding and encompassing job. And it certainly has played a role in women getting positions, because often a man can get hired first and then they can find a position for the woman, but it's often a lower level position. But I hadn't thought of, really that sort of safety aspect that you talked about, which is an interesting, yeah. I have no data to add to that, so. Yeah. Yep.
have someone. Oh, that's all right.
Okay.
Thanks for your talk. It was really great. I'm just wondering, in terms of imposter syndrome, how did you deal with imposter syndrome and not letting it affect your work?
I faked it, literally. I said, I don't feel qualified to be here, but I'm going to act as if I am. And surprisingly, when you do that, you realize that in faking it, you're actually doing it. I would say, well, I'm going to give a talk, and I'm going to get up there, and I'm going to talk like a man and be loud and enthusiastic and confident. And halfway through the talk, you realize you are loud and enthusiastic and confident. And so that's really the way I dealt with it. And the more you do that, the more you get positive reinforcement that you do belong where you are, and that you do have the ability to do what you're doing. But that was my own coping mechanism. I don't know that works for everybody, but it worked for me.
I just had a question for you. So, in being a minority in your field, do you ever feel like your work is devalued because being a woman is constantly being pointed out, or that you're constantly feeling like you have to do it like a man, like you just said? And how do you feel that doing science, just as someone that loves science, is different as a woman?
So I've never felt that my work has been devalued. As I sort of alluded to in my talk, the only place that I've really felt at a disadvantage is teaching. And that was really, for the reasons that I said, I really felt like I didn't meet the expectations of the students. And I had to spend a little bit of extra time proving myself to them. I'm sorry, and...
It was just about what you said earlier, saying, like, doing like a man.
Yeah, do I have to? Yeah, no, I think, so I find this it's a difficult question because I think that as women enter the field of physics, the culture is slowly changing. And it's becoming, one could argue, some of the traits that were really valued, which are typically associated with men, are no longer as valued as they were. So again, I'm thinking of your very typical physicist who's confident and has a huge ego and gets up in the front of the room and just lectures. That is disappearing. And I don't know if that's totally because women are entering the field, or if it's just a cultural thing where that sort of elite person in all fields is dying off, and we're all becoming more collaborative and more friendly. At the same time, I find it a difficult question because I sometimes wonder, do we associate these traits with physicists because physicists were men? Or are they really traits associated with physicists, and it just happens that physicists were men, and so most of the men had those traits? I don't know if I'm explaining myself very well. You do, in physics, have to have a degree of confidence and enthusiasm. You have to be able to stand up in front of people and push forward your idea. You cannot do that if you're small and mousy and not sure of yourself. And so I would say that at some level, you do have to act like a man. But I would rephrase it and say you need to act like a physicist. And it's just that for many centuries, men have been physicists. and now we're reclaiming those traits. Women can be confident, women can be loud, women can be sure of themselves as well. It doesn't have to be a male trait, if you know what I mean.
Thank you very much for your very empowering talk. I have two questions very related to what you just said actually. So imposter syndrome, does that ever stop? And my other question was related to behaving as a man, because I was thinking the opposite way actually, of women actually acting as men are actually badly seen. Being
Yes.
loud all those stuff, you feel like you have to do that to fit the environment. But at the same time, if you do so, I've heard so many men around me complaining of oh, that girl did that. And I feel like if actually a man did so, people would actually agree with that.
Yes.
And it would not be surprising. People would expect that from a man and not from a
Yes.
girl. But at the same time, women have to act like that to fit and
Yes.
to actually
Yes,
make
no,
it work.
I completely agree with you, and I think that we see this all over the place. I mean, we can even refer to the U.S. election as an example of what's acceptable in a man and what's acceptable in a woman. I think that this is something that was a real issue early for the trailblazers in physics. Those women were hard women, and they were seen as harsh women. They were seen as you say, their confidence was not necessarily seen in a good light. Their ability to express themselves was not seen in a good light. The same traits that a man would have were not seen in a good light on those women, but they plowed forward. And I think, similar to what I said before, I think overall the culture in physics is changing, and it's becoming more open and more diverse, and we're seeing lots of different ways of doing physics, lots of different ways of being a collaborator, for example. And so I think that as that changes, it becomes more and more acceptable for people, especially women, to behave like, as I said, a physicist, and not be seen. Anyway, that's a very long-winded answer to your question or comment. But my point is just that I think that's becoming less and less of a problem.
Do you think it's true that for undergrad we have also the faculty now? Again, your level is changing, but you think people in the younger are changing?
I have no data, and I can only speak for myself. I love data. But I would say, my own, I certainly, when I have undergrads sitting in front of me or undergraduates in my class, I value the same character traits in the men and the women. I like a student who is, like I said, enthusiastic and pushy and beats at problems and is trying to overtake me, basically. And I appreciate that in a woman just as much as I appreciate it in a man. Whether all my male colleagues behave the same way is not something that I can really attest to. But I certainly, it's not something that I see as a really big problem in physics. And maybe I'm just blind to it. But I think we all strive to be the best physicists that we can, and that does entail acting in a certain way. And that way of acting is becoming quite acceptable for both men and women.
Thanks for your talk. It's been really, really interesting. I just wanted to quickly also comment on the first question about what a scientist is supposed to look like. So I'm a biochemist, so I can only speak for my own field, but I just think it's hilarious when people talk about what a scientist should look like, because
Yes, no, it
most
is.
of the men that I work with show up in, wrinkly shirts and
Yes.
ratty jeans. So I often wonder, if women showed up dressing like that, would would that be more appropriate? Would that look more like a scientist? Anyway, that's just the mini rant that I wanted to get out. But my main question is, you've shown some really great data that there's progress being made in more representation by women in physics. And I'm wondering, and it's more visible, especially in a field that historically has had so few women. I'm wondering if you could pinpoint something that has changed to make that possible, and at the same time, what you think we could be doing more actively to kind of accelerate that progress.
Okay. So I'll just add to your comment about the wrinkly shirts and everything before I move on to your more serious comment. And that is that I think in physics in particular, and it's probably the same in computer science and engineering, the uniform is there because you need to project that nothing else matters to you but physics. And if you spent time putting your face on in the morning, putting some mascara and lipstick on, then that was time wasted. And you're not a serious physicist. And so I think that's where that comes from. And anyways, that's just a statement. So what has changed? I think a lot of different things have changed. I think society in general has changed, and we, in the span of a generation, now expect things from women that we never did. I know, I would say that in terms of the solid things that have changed in physics is the men in physics. So they now expect to have women as colleagues. They interact with women as colleagues on a daily basis. It's completely normal to them to carry on an intelligent conversation with a woman. And it's just expected that this is the way it's going to be moving forward. So I think society as a whole is changing, and because of that, the men are changing. And I think that's a huge part of it. I don't know if that's a very satisfying answer, but I think a lot of other things are helping along the way, and these are things like childcare, spousal hires. It's no longer necessary for one of you to give up your career for the other one to succeed. And when you have a situation where something like 90% of the women have spouses who are trying to do the same thing, that's a huge deal, that you can both get jobs together. And then you can have a family, and that's actually physically possible. You don't have to quit your job. So these are things that are changing all over society. It's not just physics. And so whether there's something specific about physics, again, I think it's a feedback effect in many ways. The more women, I mean, you can see that at McGill. We hired one woman, and immediately we hired a second woman, and immediately we hired a third woman, and we now have 9. And you see this anecdotally again and again in physics departments, is that they have so much trouble getting that first woman. And then as soon as they get her, it's a snowball effect. And I think that's because, again, it suddenly, there's lots of different reasons, but suddenly you get a woman and you realize she's not from Mars, like she's a normal person and she can carry out physics experiments. Suddenly she's a role model to younger students, and so that increases the number of women as well. She can argue for things like childcare. All of these things just build on each other and create a snowball effect. And before you know it, you have 50% women in the department. We hope someday. So that's my answer to that question. I don't think that it's any one particular thing. There certainly has, you can point to in the US, and Canada had this as well, where they had specific hiring practices where they tried to hire women. And I know McGill has followed that a little bit. But I have to say, especially in physics, that it wasn't very well received. There was a lot of kickback to that because in physics, as in most sciences, there's a really strong feeling that everything has to be merit-based. And you can't hire someone just because they're part of a minority. Even if you've got some really great reasons, like you want to create role models for your students. Again, I can remember being told by a friend when I got my job that I only got it because I was a woman. That's a very standard, I know other women who have had the same things said to them. And so that kind of affirmative action, I think has not, I don't want to say it's not been helpful, but I don't think it's been the main thing that has spearheaded the change. I think it's really a change from within.
Thank you for your inspiring talk. You talked about relocation. So my question is that I'm only undergraduate,
Okay.
but I'm quite older, so I'm thinking much further. I also talked to a lot of PhD student, master student, PhD student, even postdoc, and they all told me sort of the same thing. That they put it in a way that you need to relocate in progress of your academia progress, and you basically need to go where the money is.
Yeah, that helps.
Yeah,
Definitely.
and my question is that how do you balance that with, in terms of settling down, but at the same time you can potentially have to move or relocate every 2-4 years.
Yes, it's a real problem. I say it's a real problem for people's quality of life. It's not necessarily a real problem for the field because I think it does promote, I think there's a lot of really good things that come out of moving people around internationally, getting experience, moving to new groups. All of that is really necessary. But it does make it very difficult, and from a quality of life perspective. And I think the people that I've seen succeed with it have adopted a very pragmatic attitude. They've said things like, home is going to be where I am, and I'm going to make that my home for the 2 years that I'm there, and I'm going to get a dog, or I'm going to have kids, or whatever. And they don't let it stop them from moving forward in their lives. Myself, I very much put my life on hold until I was finally, in Montreal. And we didn't have kids until I was in Montreal. We didn't have a pet till I was in Montreal. And that was difficult. But at the same time, it's quite an adventure. And so, it is true that sometimes you look at your friends who are settling down and starting retirement funds and having babies, and you're still working for a postdoc salary in some foreign country away from your family. But that's just one perspective. You can also think, I was living in Amsterdam for 3 years, and it was fantastic. And lots of people never have that experience. So I think that you have to decide what's important to you. And for a lot of people, it's not important enough to uproot themselves. But it's not necessarily a bad thing. And it's something that, again, as the new generation moves, like I said, not just women, but men too, people are starting to have kids in graduate school. Those kids get pulled with them as they relocate, and they survive. Right? They do more than survive. They're happy. So you don't have to take the standard path. There's lots of different ways to move through life, and it can be very exciting.
I think that's a wonderful way for us to finish, and finally to thank everyone involved in tonight, and especially to Tracy. You've been very, very generous with sharing so much, way more than what I anticipated from statistics to your personal life. So that's incredibly generous and touching and informative at the same time. Thank you, Tracy. Thank you,
you.
Anila.
It's been lots of fun.